In the first example, we have three terms in our polynomial. We have 6x cubed, 3x, and 15. All we're asked to do in this problem is to factor. So we're not asked to solve for anything, we just want to factor out the greatest common factor, or the GCF. So we see that the variable x exists in both the first term and in the second term. So x is a factor of 6x cubed and 3x. However, it does not exist in the last term, 15. So that means that we cannot factor out an x because it does not exist in all three of the terms. If x is not a factor, then we can look at the coefficients, 6 and 3, and the constant 15. So again, factoring out the greatest common factor. So what is a factor that exists in 6, in 3, and in 15? We see that all three of those numbers are divisible by 3. So what we can do is factor out a 3 from all three of the terms. Factoring out basically means we are dividing it out. So 6x cubed divided by 3 equals 2x cubed. 3x divided by 3 equals positive x, and positive 15 divided by 3 is equal to positive 5. We also want to check to make sure that we factored this correctly. So if this is our factored form, what we want to do to check it is take the 3 times 2x cubed plus x plus 5 and use the distributive property to check to see that this factored form does match the original polynomial that we had. So distribute the 3 times the 2x cubed, 3 times x, and 3 times 5. So that equals 6x cubed plus 3x plus 15. This polynomial does match the polynomial that we started with, so that is how we check our answer to make sure that it is correct. Moving on to example number 2, we have 2x to the fifth and negative 5x. So we have two terms in this binomial, and we want to find the greatest common factor. Well, unlike the previous problem, in this problem there is an x that exists in both of the terms. So we know that x is one of the factors, and finding the greatest common factor in 2 and 5. Well, in the numbers 2 and 5, there is no common factor that they have, other than the number 1, which is not something that we are going to factor out. So the only factor that we have is the variable x. So factoring out x, that means we are dividing x out of the first term. So 2x to the fifth divided by x equals 2x to the fourth. Dividing x out of the second term, negative 5x divided by x equals negative 5. So again, all we've done is factored out an x. We also want to check to make sure that we did this correctly. So again, taking our factored form of the polynomial, x times 2x to the fourth minus 5, and we check our answer by distributing the x back into everything inside of the parentheses. So x times 2x to the fourth and x times negative 5, that equals 2x to the fifth minus 5x. Again, just checking to make sure that this is the same binomial we started with. Looks like 2x to the fifth minus 5x is equivalent to 2x to the fifth minus 5x. So our answer is correct. In the very last example, we have a trinomial. We have 1, 2, 3 terms. So again, just like the previous problems, we want to factor out the greatest common factor. So what do all three of the terms have in common? Well, immediately I see that there is an a that exists in all three of the terms. Not only is there one a that exists, but there are actually two a's being multiplied that exist. There is an a times an a, or an a squared, that exists in all three of the terms. Again, we are factoring out the greatest common factor, not just any factor. So a squared is the greatest common factor amongst the a's. Continuing on, looking at the rest of the terms, we see that we have b to the fifth power, b, and there is no b in the third term. So even though we have a b in the first term, we have a b in the second term, because there is no b in the third term, we cannot include the variable b in our greatest common factor. So we're not going to include b. Let's look at the coefficients. The coefficients are -8. We have +4 and -12. So again, factoring out the greatest factor, so what do all three have in common? We see that factors of -8, we include 1, 2, 4, and 8. In the number 4, those factors are 1, 2, and 4. In the number 12, factors 1, 2, 3, 4, 6, and 12. So again, the greatest factor that exists amongst all three of those terms is the number 4, meaning that we can factor out a 4. So our greatest common factor is 4a squared. So 4a squared, the first term, -8a squared b to the fifth, divided by 4a squared is equivalent to -2b to the fifth. In the second term, 4a cubed b divided by 4a squared equals +1ab. And in the third term, -12a squared divided by 4a is equal to -3. So again, just to see where I got this, I took the greatest common factor, 4a squared, and divided it from all three of the terms in my trinomial. Just to check that I did this correctly, again, I'm going to take my factored form, 4a squared times -2b to the fifth plus ab minus 3, and I'm going to distribute the 4a squared to all of the terms. And I want to check to see that I get the same trinomial that I started with. So 4a squared times -2b to the fifth is equal to -8a squared b to the fifth. 4a squared times ab equals +4a cubed b, and 4a squared times -3 equals -12a squared. So I'm going to compare this trinomial to the trinomial that I started with up top. For number 3, I see that they are the same, so I checked and made sure that my answer was correct.